infrastructure that enables that. You could think of 3D printing in the next step. How much goods is it that today is being produced and shipped from A to B that could be downloading a file over a broadband network, and then you print the device on the local site? And I think the automotive industry, particularly with some subparts, are looking into and benefiting from this. Even in advanced things like medtech, the digitalization is enabling totally new way of transporting things, and with a positive effect of reducing the emissions. Then we have also found that in this ICT deployment, I should say also that the ICT industry itself, of course, consumes energy. Roughly 2% of the global emission comes, or expected to come, from the ICT sector. And there is roughly 2/3 from the traditional fixed ICT and 1/3 from the mobile networks, and where we, thanks to smarter, smaller device with better energy efficiency and with a user trend that is now moving from the fixed networks to the mobile networks. And we are calculating on a, what is it now, 7-time increase of mobile traffic until 2025, I think, something like that. So it's a huge increase. And of course, the energy consumption in the network cannot be proportional to that traffic increase. So we have a number of initiatives to really have more energy smart networks, to use renewable energy provisioning on the mobile network radio base stations, and to do that in a much more creative way of increasing the capacity of the network and so forth. So both the energy consumption and the emission from operating the communication networks and the indirect impact on the areas where it's being deployed. And we were discussing here before one example where I think it is important to realize that the sustainability reasons for implementing a solution can also be driven by commercial reasons. It's not so that it might have been for a number of years that, well, it was greenwashing or it was purely for the good sake of being more environmental friendly. Now I think we see that the commercial strategy and the sustainability strategies are really hand to hand. And one example is that we did for a Danish company that you might know, Maersk. Maersk is the world's biggest shipping operator. They're operating some 440 container vessels. They came to us with a challenge. They have today climate-controlled containers. That's nothing to do with the global climate, but really the goods that needs a fixed humidity or a fixed temperature. These goods can be supervised today in so-called reefers. Those reefers have technology in it. They have a GSM module. So when this container is in the harbor, in the railway, on the truck, it can be supervised and monitored. But the biggest part of the trip is going on sea. And there it was really into the dark, no connection, insurance premiums going sky high because you don't have control of the goods. And we said to Maersk, well, why don't you build a mobile network on the vessel? So at the end solution, we have now built mobile networks on 440 container ships with coverage in a heavy metal environment that puts no limitation to where these containers can be placed. And now that was a business case that motivated the implementation of equipment and a satellite backhaul that can be on for the whole trip. That doesn't have much to do with environmental, you say then, but indirectly it has, because now when this is implemented, the satellite connection is on. And now it means that the fleet management center all of a sudden can keep control of the route and say that, dear captain, you're not really optimizing the route. So if you go a little bit slower or you go a little bit to the other direction, you will save crude oil. And anybody who knows emissions know that crude oil is not really the most environmental friendly thing you can put up in the air. So now the biggest positive business case for that whole implementation is the saving of crude oil. So again, just an example on how ICT can contribute to both the environmental at the same time as it's commercially sound. So that's just a few examples on a few minutes from an ICT service provider and equipment provider side.
Many thanks, Olli. So now it's to you, Eric. I have an initial question to help you starting your talk. There is a lot to do on further decarbonizing transport, especially road transport, of course. How does the automotive industry look at ITS as a way to contribute to decarbonization of road transport?
Yeah. Well, it's an important question, especially, and I see a representative of the Commission here. The Commission is indeed planning to come up with a communication on decarbonization of transport in July, kind of for all transport modes, giving some perspective on how, in fact, also to bring alive some of the ambitious goals which have been set in the climate and energy package of last year to further reduce greenhouse gas emissions, how to bring it alive for transport. Yeah. Clearly, decarbonization is currently high on the agenda of the automotive industry. Everybody's looking at the automotive industry when talking about decarbonization these days. Not only, of course, in the context of climate change, but also in the context of air quality. And that's, in fact, my first point when we are embarking on this type of discussions. That is that it's going to be increasingly important that we start looking at solutions which help us moving forward on reducing emissions on all fronts. Not only CO2, but also the pollutant emissions like NOx. And that has been a bit an issue until now, as being illustrated by recent incidents. That we had in Europe perhaps a focus on climate change, less on air quality, with also initiatives which were also taken at national level to focus on technology reducing CO2 emissions, rather than looking at air quality, which has led obviously to a market in Europe which has become predominantly a diesel market. I mean, 17 of the 28 member states in Europe have tax incentives to encourage the adoption of diesel, because it had, of course, as a big benefit that it was more fuel efficient, so you consume less, and you emit less CO2. So that's kind of, for us, the first thing, let's look at solutions which are able to kind of address all emissions. Yeah? So there is a need, and especially when we talk about finding then solutions for the issues in urban areas, we need to bring that together. For us, we have done in the automotive industry over the past years a lot trying to address emissions, focusing, however, perhaps too narrowly on powertrain technology. How could we further optimize fossil combustion engines, to reduce CO2 emissions? And then, of course, increasingly work on alternative powertrains, including electric. I think next, and this work will continue. We clearly need to do even more in these areas. Yeah? So, but next to that route, I see now connectivity technology, including ITS. I would not say just ITS or cooperative ITS, but connectivity technology, and in the future also, autonomous driving vehicles, as another route forward to see how we could further reduce CO2 emissions. The problem, of course, when you talk about ITS in particular, has been till now, do we know enough about its CO2 reduction potential? And one of the things we are good in Europe is running all kind of pilot projects. We have plenty of them, left and right, North Europe, South Europe, East Europe, Western Europe. And we have the tendency to embark each time on another one, without kind of capturing the learnings and see, is there anything which we got out of it? And so what we did within the automotive industry, we charged Ertico, who has been involved in lots of these pilot projects, to not do any new research or projects, but try to capture what we learned from the different pilot projects which happened across Europe. And to start to map it out. To map out what are the technologies which are out there and which is their CO2 reduction potential. And it's interesting to hear my colleague here from Ericsson talking about, you kind of gave an estimate of 15% CO2 reduction potential, overall. That's in fact also the bottom line of the Ertico study, looking at all the different ITS applications, both in vehicle as well as infrastructure related. On average, that's also the figure they say, that would represent a CO2 emission reduction potential by 2030 if we would more systematically implement these technologies. Again, we need to make a big difference. There are lots of technologies out there, lots of applications, a lot of features, and some have more impact than others. Clearly, one of the biggest opportunities which were highlighted by Ertico in the study was, eco-routing, eco-navigation applications. Yeah? And then when it comes to infrastructure-related ITS, especially the ones who are dealing with traffic management. You have this project which was set up in, I think it was in Munich some time ago, which showed again a CO2 reduction potential of up to 20% if you would be able to really better manage the flow of traffic by better coordination of traffic lights. So again, we see this as something which has big potential. Yeah? But to be honest, the problem we try to address with climate change is so big, we should not say, okay, that's now going to be the only way forward. We as automotive industry will continue working on powertrain technology, but ITS becomes another area with high potential. For us, it's also important when you talk climate change to look not only at what can be done through vehicle technology, but also looking at how the vehicle is used and how that has an effect on emissions. And then you come to things like infrastructure, you come to driving behavior, where again, driving behavior can be influenced by technology and can be influenced by ITS applications. And in that respect, it's worthwhile to share an anecdote when we last year brought together around 50 stakeholders from different sectors to learn from them about what is CO2, how could we as automotive industry do better in reducing CO2 emissions. And we got a story shared by a big fleet owner in Belgium, the Postal Services. Because we often overlook the fact that you have, of course, private citizens, but there are a lot of organizations out there who are owning big fleets. And they attached a lot of importance to eco-driving. And in such a sense that, drivers who were following eco-driving courses, and they had also eco-driving features, ITS features, in the vans of the Postal Services. So those who delivered could get a bonus at the end of the year. So there were incentives built in by the Belgian Postal Services to encourage their drivers to drive in an conscious or savvier way. Yeah? And there were incentives built in to that. And that opens again some new ideas on what could be done in order to address this bigger issue. Because we are in the automotive industry convinced that, first of all, it is a big issue. We need to address it. We need to address it. But frankly, we're not going to be able to address it alone. We need to do it jointly with others. But we need to do it in a coherent way. And it's joining forces with everybody will allow us to identify new opportunities and what can be done better. So, just some ideas on our side.
Many thanks. Jean Bergogneau, it's your turn. You have a presentation. We'll just launch it and present. Tu lances? D'accord, ok. Attends, non, vas-y. Okay. J'essaie de lancer et je vais introduire un peu. I'm trying to launch it. No. Could somebody help?
It's on the bottom.
I have difficulty
the screen on
to show.
Slideshow.
No.
From the beginning?
Yeah. It's in the bottom.
This one?
Ah oui.
Oh,
On the screen.
yeah.
Okay. Okay, many thanks, Jean. So, tu as avancé. Along with Topos Aquitaine, the ITS regional cluster in Bordeaux, ATEC ITS France, your organization, took the opportunity of the ITS World Congress in Bordeaux to announce a new transport initiative, very ambitious, called ITS for Climate. That was later presented and considered at COP21 in Paris in December. You were able to obtain from that a number of ITS bodies and industrial partners around the world agree on joining the initiative ITS for Climate. 8 months later, beyond the initial idea or ideas or project, where is this project, ITS for Climate? How does it develop in terms of goals, rational perspectives? Do you feel that a significant mobilization is emerging that makes sense against global climate challenge? Please.
Okay. Well, I'll try to do it short, but the question is multiple phases. Yeah. Well, monitoring CO2 emission is on the road since several years, maybe tens of years for freight and logistics. It's fully implemented in other fields, like economic activities such as housing. It's more recently that it has been seen as a major issue in public transportation and personal travels. So why? Probably I will focus on the problem of personal travels in urban travels. Transportation contributes to up to 30% of CO2 emissions globally, and probably urban transportation will represent a growing part of these emissions. So focusing on urban mobility is probably a priority for us. Since up to recently, urban planning and public transportation have been seen as efficient tools to monitor greenhouse gases emissions. Through a better management of urban development, optimization of urban mobility, lowering daily mileage in day-to-day activities can be achieved. So developing efficient transportation by routes, routing, capacity management, high capacity and high speed networks linked to flexible suburban secondary networks are necessary for a future of the city more efficient and easy to live. However, not everything is solved. Planning, designing, constructing of such infrastructures takes time, and very often transportation runs after urbanization. Urban projects and transportation projects have their own cycles. So we have different public authorities, different political circles involved, different life expectancies. Urban planning is for hundreds of years, as transportation may be for 10, 20, 30 years. Different goals and dilemma, conducting to very long and difficult decision process, and sometimes results which are not in converging with the original game or aims that we had. So should we wait and see? No. We think that ITS offers a range, and it has been said before, a range of solutions which could complement those middle terms and long term projects. Within the 5 years between the launching of a project and its real operating phase, we can develop very easy to develop and easy to run solution to optimize CO2 emission. But the problem is techniques are very numbers. Like you have hundreds of technical solutions, and they may have counter effects between them. So how to optimize that? I will give you some examples. ITS, I think that everybody knows, but different type of solution that you can use for traffic engineers and mobility. We can talk of traffic regulation system, dynamic line optimization, free flow or urban controlled traffic zones, toll system for urban traffic, For example, in the city of Paris, in the suburbs of Paris, a project has been developed, and just by optimizing traffic lights, optimizing speed limits on the highways, we expect 10 to 50% of CO2 savings. Same data for projects in LA and Pittsburgh in the US. And I have another example in Austria with Salzburg and Graz, with 20% of expected savings. For public transportation, we have about the same kind of technology. So information system, regulation, SCADA system for traffic, bus traffic or metro and railways operation. We have ticketing, which is an attractive way to shift modal, for modal shift from car to public transportation. Management solution for parking, for optimizing logistic activities in cities. I have some example here from Österreich, and also different now technology based on digital systems, which are very often based on smartphones. Eco-driving was already mentioned, and all type of application which encouraging you to modal shift. One example, this system, which is a possibility to give you information, to give to the driver information on its mileage and other information about security. This one about incentive, it's developed in Bordeaux, so southwest of France, and it's an incentive to people from left their car in parking lots and shift to public transportation. I could talk also about freight with the same type of application. Now, so what we can say with that variety of systems, that ITS solutions are on the shelf and are ready to deploy. They are space saving and environmentally friendly. That means that you can deploy the solution with little impact on infrastructure possibly and side effects. They can also minimize cost of operating and construction, and have also possibility to have a better monitoring of the social impact or economic unemployment. But are there the unique solution? Probably not. And the difficulty is that you can develop in the same city different technology that could be opposite and that could not rise themselves. So that's a big issue now, is to decide if we can put together all those technologies to have a significant impact on CO2 emission in cities. As we saw before in my explanation, is that ITS primary objectives were not climatic and environmental issues. They were intended in improving quality for mobility and to allow easy and get more fluent conditions for traffic and mobility inside cities or in general. That means that they were not dedicated to optimizing the emission of CO2, they were not dedicated to optimizing pollution emission, pollutant emissions either. So that means that there are only tools. There are tools at the service of public authorities, but they are not solutions by themselves. So I can give you a lot of examples. You can deploy technology like toll in the centers of cities, and just that solution will either induce modal shift to public transportation with a global positive effect, but they could, in other situations, just push people to let their car or just go around the core of the city and the emission, global emission, could be just almost nothing. Or the economy on the lowering on pollution will be nothing. So that means that now the project that we launched was in two directions. We need to get a better understanding of individual techniques, so that means each of the solutions that were pointed out has to be evaluated. Pre-evaluation is already made in some cases, but post-evaluation is rarely made. We have to measure what type of effect we can get, what type of direct effect, edge effect, or negative effect each of these technology can have. And we have to organize the return of experience, developing evaluation techniques and metrics, and developing information about those technologies. And the second direction in which we try to work is to develop a comprehensive methodology for public authorities to evaluate their own situation, the situation of each city, and to try to find the right panel of solutions that they could deploy depending on their objectives. And so far we have little return of experience, or maybe you may have some. Thanks.
Thank you, Jean. Okay, Stephens, it's up to you. As I didn't have a chance to see your presentation before, so it's discovered.
Yeah.
Anybody, please.
Thank you. Let's see how this works. We are few, but very efficient planners and business people working for a better climate. And I just wanted to start to look at a few megatrends influencing our cities that I will address today. The urbanization, the climate change, and new technologies. First of all, I think most of you know already that the City Council of the City of Copenhagen has chosen a very ambitious goal to be the first carbon neutral capital by 2025. And I will address some of the means that we are going to use to reach that target. But first of all, perhaps it would be important to look at some of the challenges we have. This figure shows different areas of CO2 emissions, and you can see that, for example, if you look at electricity, the impact from 2005 to 2014 has been very positive, almost halving the CO2 emission. And in opposition to that, you can see that if you look at transport, we have only reached a decrease on 7% over the same span of years. So it's just an example that talking about climate, talking about CO2 emission, the challenges in the transport sector is very, very difficult for at least our cities to confront. So how can we turn these challenges into new opportunities for urban mobility by using ITS? We need a clear policy. We need a strong political commitment, and I can say that the City Council in Copenhagen is really committed to reach the CO2 targets. We need new ways of cooperating. We have tried several ways of cooperating in the City of Copenhagen. One of the very successful ones was a PPI process before the last tender on ITS, where we worked together, businesses, research institutions, and public authorities, to develop innovative ideas as to how we could reach the CO2 target by means of ITS. Urban Lab and work across academic disciplines to create synergies. First, let me address the clear transport policy. We have a mobility plan with long-term goals, and in particular, how to address the modal split. We have short-time service goals, including reduction of travel time or number of stops for cyclists. We have a priority strategy, bringing all modes of traffic into planning, and ensuring a clear priority strategy to target the use of ITS. So, how should we develop a new ITS solution to reduce CO2 emission? And I think there's a number of approaches, and our conclusion is that we need all of them, including planning, market-driven, science-driven, and user-driven approaches to develop our ideas. And the ITS investments must be targeted to the actual needs of the users to have full effect. The city of Copenhagen's provide access to make live demonstrations or test in the streets, and actually tomorrow the mayor is inaugurating a street lab in the streets around the town hall, where we are testing a number of sensors. It's sensors for measuring traffic flow, parking, air quality, litter management, and a number of other issues. So testing these sensors in a more holistic way and looking on the experiences as to see whether or not we will be able to roll out these experiences on a broader citywide manner. We work on creating synergies. We have seen a number of cloud-posts in the last years in Copenhagen. Paris is the one recently. So how can we manage to make holistic solutions when we do our climate adaptations plan, doing development for cyclists and doing ITS at the same time? And I think basically what we see in Copenhagen is that the climate adaptation solution is so comprehensive that they will fill in our capacity for new projects over the next 10 years. There will be very little other investments in new bicycle lanes or extensions of the infrastructure. So that's another argument that we work within the existing infrastructure and, for example, use the infrastructure more efficient by ITS. So I will conclude my presentation just to mention a few examples where we are developing ITS in concrete and specific solutions, and most of them are actually coming out of the PPI process we had a few years ago. First, the green drive behavior. It's an eco-driving approach, and it was actually an approach that we developed together with a number of other cities and Ertico, funded by the EU Commission in the Compass 4D project. And you can see the drivers will have a small onboard unit where you can see the speed. Here you have 45 kilometers per hour, and then the bar is green. Following 45 kilometers per hour, the driver will have a green light next time, and he can have an indication that he can slower the speed and then have green, or increasing the speed up to the speed limit, 50 kilometers per hour. And of course that means that there's more fluent flow for the trucks through the city. There's less consumption of fuel, and also our questionnaire shows that the drivers have less stress in their daily life as drivers. So it has actually been very successful. In the Compass 4D, there's also a traffic safety perspective where the bus driver will have alarms if there's a risk of traffic accidents, for example, driving for red, then the driver will have an alert on his onboard unit so he can take extra care. And in future, of course, we can develop that further so the driver will have some automatic assistance systems for braking. Traffic signal optimization is a very important measure, and actually half of our investments is going to traffic signal optimization to get better flow for cyclists, buses and cars. And the City Council has decided a network for prioritized cycle routes, a network for prioritized bus routes, and a network for prioritized car routes, so we can optimize based on the streets and parts where there's most bicycle traffic or most car traffic. And of course there are some places in the city where we have to compromise between cycling, biking and buses. Then we have the intelligent bus priority system. We've managed to get the server from the public transport company to work directly together with our server for traffic signals with the help of Dynic. So we know, or actually our traffic signals knows today exactly the position of 1,000 buses, and we have a number of intersections where we are giving bus priority. So when the bus reaches an intersection with a risk for getting red, automatically we can give, for example, 6 or 10 seconds extra green time, so the bus will go through and save time for the passengers and save fuel as well, because stops are really very expensive in fuel consumption. We also, this has not a lot to do with CO2, but in the long term it might have, because integrated use of data between street lighting and traffic management is also an area we will develop further. We have an over-representation of accidents with cyclists at night time when it's dark. So we are getting our street lighting management system to work together with our traffic management system. So when we detect the cyclists in 5 big intersections in Copenhagen, we will light up instead of dim, so the car driver can see the cyclist. They will be more visible, and then it will be a smaller risk for traffic accidents. And this will be implemented in 5 intersections in Copenhagen during the next 1 year. And then we are having a very interesting example or development together with the National Road Directorate. We have moved together in a traffic management center, the City of Copenhagen and the National Road Directorate. And we have brought into a new traffic prediction model where we cross municipal borders can predict traffic situations. We can plan for major roadworks. We can take steps if we have traffic accidents, so we can get smoother traffic around those situations. So travel information is part of the cooperation we have with the National Road Directorate from the traffic tower, as we call it. The travel information system will help us to stimulate modal shifts, pedestrians, cyclists, buses and trains in the future is a very important part of the solution in Copenhagen. And finally, I will invite you to the ITS World Congress in Copenhagen to see those, some of those innovative ideas in practice. September, October 2018, with demonstrations. Copenhagen one-to-one will be some of the examples you can meet in the streets and squares in Copenhagen, and a number of technical visits. So welcome to Copenhagen.
Thank you. Oh, yeah. Thank you, Stephen. So about the fact that all of us will be in Copenhagen and happy to be in Copenhagen in 2018. Do any of you ever the need to react or on the talk of any other speaker?
One reflection there, I think,
Yeah.
that it's said a number of times, the whole world of Internet of Things, the whole deployment of sensors giving data for judgment on situation right now. You already described that in how you do that partly. We have seen interest in perhaps doing dynamic congestion charges depending on how much emission are the vehicles doing. Can you create incentive for modernizing the vehicle park so that the latest, most efficient engines are really deployed and so forth. I think the whole notice of sensors, regardless of who deploy them, the whole sharing of data, again, not a new topic for this, but I think it's combining to a number of topics that are in all the other sessions. And if we don't solve that, and if we don't, so to say, make this data available, try to make commercial maximization of it, then it will be hard to do the cross-sector deployment, because I think cross-sector is the key word here.
Yeah.
Electrification of the transport system, and we deal with the energy sector. Here we sit and talk about ITS as if ITS is the whole of the world. When we are on electric or utility industry conferences, they talk about smart grids, and smart grids is the only thing they care of. Smart grid and ITS need to come together, sharing data, sharing tools, and I think otherwise it will not happen.
Yeah.
Just a small reflection.
No, but I completely agree with that. What we see in the automotive industry, in fact, the two big trends, we heard a lot about trends, but I mean, it's digitalization of industry on the one hand and decarbonization on the other hand, which come together and which can provide unique solutions here. Yeah? One of the big questions coming out of this discussion remains, and we've seen that also from the Article study which we received on the potential of CO2 reduction potential from ITS solutions, is how do you measure that? Yeah. There is still a lot of inconsistency on how the CO2 reduction potential from ITS, how you measure that. Okay, so I think it's going to be very important that as we are trying to look at this further and try to embrace this as one of the many tools in the toolbox to get emissions down, that we get a better way of measuring CO2 reduction potential from ITS. That's going to be a big one. Another one which I see, I mean, the reference was made to the fact that all sectors go down when it comes to reducing CO2 emissions, and transport is up. Just want to add here perspective, because it may sound like, okay, does that mean that the manufacturers of vehicles don't do anything? I think on the contrary, I think we've seen more and more new technologies reducing CO2 emissions. Having said that, as the economy relaunches and boosts, of course, it triggers more transport. And that's the big challenge, you know. Of course, there wouldn't be any emissions if all the cars and all the trucks would stay on the side, yeah, and don't move. Yeah. But of course, an economy, as economies are booming, there's more transport of goods, especially on that side. Also, people are more mobile, and so this is something we need to take into account. I mean, we've seen that when you look at transport of goods, 70% of transport of goods, or even a little bit more, happens still over the road. because a lot of the logistics companies would say it's much more effective, it's much more efficient, it's even more cost effective. So we need to look at that as well, cost effectiveness of solutions, because some of the solutions we talked can be very, very expensive. But I think there, in order to address transport, I think we need to look at integrated transport solutions, and again, ITS can help there. How can we are not very much in favor of this modal shift concept, as you can imagine. I don't think that's the way forward. It's really looking at all the modes. There is a role for every transport mode, but how can we integrate them more effectively? And that's for both moving people as well as moving goods.
Any other of you? John?
Yes. Well, it's difficult to talk of ITS because ITS is a so large brand of technologies that there are ITS in cars when they're communicating cars. There are ITS in roads with induction with electric cars. There are ITS everywhere, even in ICT. So it's very difficult to have a global opinion of what ITS can provide for. What is sure is that in terms of traffic or modal shift or public transportation optimization, those solutions are on the shelf and they can be deployed very fast. They are not long-trend solutions. I mean that they are not solutions for 20 years. The population will grow, the technology will evolve, and the needs in 20 years will have no right and no common sense with what is the need today. But there are solutions for short terms, and they can help to deploy those new technologies into cars. I mean, having a complete replacement of the cars, it's about 3 generations, 4 generations, maybe 30 years. We don't have 30 years to have more efficient transportation. Within those, then we don't have 30 years to replace roads for more modern, more technology, and more effective public transportation. We have very short-term solution to find. ICT and what they allows in technology for optimization of what is existing is really a good opportunity. But I'm not sure, and one question for you would be, do you have some figures on the impact of those technologies? Can you monitor the effect on CO2 emission? And can you then try to figure what part of the gain is coming from this technology for eco-driving or from bus priority system? That's a big issue, I guess.
That is very difficult, but we have some models of calculating based on data from traffic management, and we are having increasingly concise measurement because we are getting real-time information on traffic flows from GPS, for example, and extending a network of stretches in the city where we are actually measuring traffic flow, stops and starts, etc., etc.
And can you make a connection between the CO2 emissions that you can maybe monitor with some captors and those technical devices that you have on the sidewalks and streets?
I don't think we can do that exactly. As I told you, we are doing some calculations, and we can compare streets where we have installed these ITS solutions with streets where we didn't. But basically, I think it's difficult to measure.
The project that we are aiming at developing with Topos and ITS France is trying to get some logical and scientific rules that could make some prevision on the impact of those technologies. Yes.
And we are working together with the universities to do it.
So we could work with you.
Yeah.
So.
Right.
Ole?
No, I was just thinking now, it seems that we're all saying that we measure what you measure, you manage. But do we measure in a way that it can be interpreted and can be, so to say, neutrally judged what's good and what's bad? I'm not sure if it is applicable, but we have since mid of the 90s collected data, and we are doing in our research branch quite advanced breakdown of every single activity in the whole life cycle management, from sourcing of raw material to end-of-life management of all our activities and translating all those activities to CO2 impact. And for anyone being interested, would be happy to share in that methodology. And as I said, that has been peer-reviewed in the research community as well. If there's something that are of interest also to share methodology, then numbers can be more easily interpreted.
Wow, thanks. About the measurements of CO2 environmental, maybe safety benefits. You have, let's say, alleged benefits, expectations of benefits, what is announced in media, politically, etc. And you have many, many figures here in this Congress and around about CO2, etc. And you have very few real figures of proven performance sensors, real CO2, linking to, most of the figures we have are from modelization or from nowhere. So we have clearly on the field of ITS solutions the need for independent scientific assessment of advantages, environmental, climate, safety, etc., based on standard real measurements and methods. How and from where could emerge such a worldwide evaluation capacity that could obtain some consumer confidence? That's the today problem. You have to put figures, objective figures, and you have to gain the confidence of the users. We know, all of us know that these 2 years on the automotive market, we have some like a loss of trust of the consumer of what is certified as results. So in this atmosphere, how could we, in the ITS field, build some collective system, network, that could put on the table figures that are real and that could get the trust of the public? Anybody? Ideas? ITS for climate. We need some tools.
If we launched the project ITS for climate, it's because we are lacking that type of information. But we do think that individually, each technology is well known now. Most of what we have talked about public bus priority system or traffic light management and so on, they are known, and we have some feedback on each of them, their capacity to limit the congestion, limit the mileage, the average mileage of cars and so on. Eco-driving, we have feedback of eco-driving system which tells us that we can gain about 10% in the car consumption. That's real fact. What we don't know now, if we put all those technologies together, what will be the result? When we're working on the scale of the city, should we work on the central part of the city, the dense part of the city, the whole place and all the mobility basing for and that is quite different. If I'm using electrical cars and that there is a plant using coal producing the electricity, what is the global gain for the community? It's not sure. Probably the air will be and the weather will be better inside the city, but the pollution will be outside. So that's very, I would say, critical argument. The problem is a systemic problem that we have to calculate the global impact of all of the situation on certain territory. In this part, we need some research now, but not on the individual techniques.
Eric?
Yeah, what I would like, I agree with that. Having said that, and I think you mentioned it earlier, we all have data, and it shows, once again, how complex it is to measure impact on emissions. I mean, it is always technically very, very complex, especially when, then here in this case, you try to measure the implication of a variety of features, because you talk really about a wide variety of ITS applications, especially when it affects transport, both in the vehicle or outside the vehicle, infrastructure related. So I think one of the things to be done would definitely be that we start to classify all these features. I mean, currently there are different. Everybody is classifying it a bit their own way. Yeah. Should we kind of try to cluster some of these features to start with, given their intended application, given the impact they could have on emissions, so that at least you could start measuring groups of ITS applications, or instead of trying to do it, with one fit all approach, which is probably almost impossible. Having said that, again, I mean, what we all already know, without knowing exactly how much, ITS, and that has, I think, been confirmed by all of us here, has clearly some positive impact in reducing emissions. So it's again something which we should further promote, advocate, and look at. There's a lot which has been done already when it comes to research, studies, pilot projects across Europe. I think it's time to consolidate all these learnings. When it comes to cities, I mean, the city of Copenhagen has done some terrific work. Other cities, Helsinki, I mean, Bordeaux, Strasbourg, they all have done beautiful work. How do we consolidate all the learnings from what happened in the cities? Because it seems for the moment a bit like, everybody competing with everybody, and it's like a beauty contest. And at the end of the day, we want to make sure we learn from what everybody is doing and try to consolidate it into some sets of best practices, also when it comes to measurement.
Could I add?
Ole, oh,
No, go ahead.
yeah, okay,
Stefan.
please,
No,
Stephen.
yeah, because I would like to build on top of that, and I think it's correct that as a city we deliver services to the citizens. It's not our primary task to do research and evaluation. So when we sometimes join other cities and project funded by the European Commission, there's always an evaluation component in that. So that's the first thing. That's an advantage, because then we learn about the impact, and we work together with other cities and private companies, research institutions. And I think the other element is exactly what you looked for, that cities together with the European Commission can support standardizations, harmonization, as it actually happened with the Compass 4D. The on-board unit that we used in Copenhagen is a standardized size unit, and it could be used in many other cities in Europe, already in Bordeaux, already in Vigo in Spain, and Verona, and hopefully this standardized unit in future can be used in vehicles running all over the European countries.
Ole?
I'm sitting here thinking if we should group the ITS application, or if we should look at the good cities. And I tend to look more. I think it's very encouraging to see what the city can do. I mean, the urbanization is an urgent problem. The city is the first to feel the bad effect of emissions and so forth. And I think it's perhaps the wrong starting point to look upon ITS as such, but rather look upon the city challenges, and then if we call it ITS or call it something else, it's less important. So lower the focus on ITS and increase the focus on the need. And I think one of the need is we as consumers. This is to a large extent a behavior change thing. And if we can by collecting information, sharing information, make more conscious decisions on user level, and that can be. I mean, look at how many of, I'm not sure if we are a representative group here, but how many of us are using this sort of devices that help me now all of a sudden to understand my heart rate, to understand how I sleep at night. And it gives me data to say, oops, is that the way I'm behaving? So I adopt and I change a bit. if we can present environmental data in a much more flexible and easier access way to make my travel choice, or if I'm a purchaser of transport goods, I mean, make conscious decisions, make me have easier to see what is the real emission of the modern fleet at the haulier that I'm using, instead of a standard theoretical calculated average number from a big fleet where you don't see who are investing in environmental friendly fleet and using an old strongly emission fleet. So enable conscious decisions on individual level, on company level. We have moved in the last year heavily. I think we are a big shipper. I think we have something like 1 billion ton kilometers or something like that, shipping goods all over the world. And we have done a major shift in just 1-2 years from air cargo to sea. Yeah. So with primarily the emission statistics at hand and the facts. But it's very hard as a conscious transport buyer to get the true real life emission data of this shipment. And there I think the ESAP, the enabling of sharing data, collecting data, not to request that it should be perfect from day one, but at least start. I mean, I don't trust more than half of the heart rate I get from this one, but it's good enough. It gives me a change. So collecting data, sharing data, allow the developer and the innovation community to find out what it is. Smartphones were not what it is today if it wasn't for the innovation community doing apps on data that nobody would have thought were interested until it came in the hands of a app developer. So publish data. Collect and publish data.
Well, I've heard about user or consumer needs. I just suggest that most of messages from both the industry or the public authorities here in this Congress and on the great ITS family point the capacity of ITS solutions to meet actual user needs against the old criticism about technology-driven innovations and so on, and out of the scope. But the recent innovation waves, such as the smartphone revolution, smartphone saga, show that prior user needs are unexpressed, or simply that the concept of prior user needs in the field of 100% innovation makes no sense. You have no expressed needs, it's hidden needs, or we don't know what. So both the industry and policymakers are, by the fact, in the innovation field, are building the consumer desire. Let's speak about desire, what desire to buy innovation, desire to find new factors of economic growth, and so on, much more than unexpressed existing mobility needs. So user needs, mobility performances, environmental or climate benefits are not central in the mechanism of innovation deployment. Would you agree with that? Yeah.
No,
please.
I would completely disagree with that.
Please.
I mean, as I said already yesterday, I think, I mean, the idea that you can push technology to citizens is not realistic. That's not what is happening. I mean, if you are in a consumer-facing industry like Ericsson or like the automotive manufacturers, I mean, your business model depends from whether consumers buy your product or not. So you cannot just impose anything, you know. So it requires ongoing market research in ensuring you understand what the needs are and how you can, in fact, better meet those needs of consumers, but at the same time also policymakers, because some of the issues we try to address when it comes to mobility solutions are private needs, but also society needs, especially when it comes to mobility, yeah? And try to combine both. So and I think their ITS allows you to come up with solutions which better meet both the needs of individual citizens as well as society. As I mentioned yesterday, I mean, we know that when citizens are in front or in the showroom and need to select a vehicle, The drivers for them going to be, first of all, the cost of operating the vehicle, fuel cost, the fuel consumption. It's going to be one element which is driving it. Second is safety. And third is convenience. Yeah? And so when you look at ITS applications, they can address these drivers. And we talked about ITS applications which help to control fuel consumption, especially when it's about traffic management systems. We talk about a lot of ITS applications, driver assistance systems, which are very safety-oriented and safety-focused, yeah, and enhance the safety of the driver and the others driving with him or her. And then convenience, a lot, I mean, especially when you look at commercial vehicles. We talk truck platooning. I mean, this is driving efficiency of the logistics companies. So if you are able to kind of come up with applications and features which better meet the needs of your customer, I'm sure there will be a demand for it. Now, having said that, there are some challenges. It's the cost, because all these applications cost a lot of money still. And so how can we continue reducing the cost of these applications to make them more accessible and affordable? Second big challenge, I think, for manufacturers as well is the need to do more when it comes to communication. How do you inform your customers about all these applications? How do you educate them better on how to use them? And I'm sure that in the future this will trigger especially interesting new opportunities for the dealers, because with the digitalization, there are a lot of dealers out there who are concerned about their job for the future. But frankly, as cars and vehicles get more sophisticated, there's going to be even more of a need to inform, educate the customer on how to use it effectively and efficiently. And so dealers next to OEMs will have a bigger role to play to engage with the customer, to explain it to them.
Any other of you? Yeah.
I think there's an interesting balance between sort of the individual behavior and the regulation that society is put on.
Yeah.
I think the society can perhaps sometimes, or the governments sometimes can push a certain technological development. If you look at Norway, for example, the government had chosen to give incentive for electric cars, and I don't know if the number per inhabitant is the biggest in Norway, but at least one of the biggest in Europe in comparison to Denmark, where we have less incentives for electric cars. And also, I think electric cars match Norway's resources very well, because Norway has a lot of water energy. So I think this balance between how we as individuals behave and how governments can push a certain technology is very interesting.
All from the room on these issues? Technology-driven innovation, needs of the user, balance between individual needs and collective consideration. Yes, please.
My name is Stephen Thompson from Transport Scotland. We're an agency of the Scottish Government. I have to put advice to ministers on climate change. ITS is one of them. If I've got 2 pages, or change that, if I've got 1 page of space to sell ITS to a minister on climate change, what should be on that 1 page?
Wow.
Because that's the only thing that matters. Not the driving public, not me as the road engineer. It's the minister making the decisions that will inform what happens out in the real world. So what goes on that 1 page?
Somebody could be of help, of any help.
I don't know the government, but I can see in the city council of Copenhagen there's a very broad political support to ITS solutions, and basically I think it's because the politicians can link the technology to the needs of the citizens, quality of life, better flow, better mobility, improved traffic safety. So that would be my one-pager.
It's half a page. Okay. Is it? Jean?
A few lines. The problem that we may have with politicians in France, at least, and they like nice things and things that you can see. And very often ITS are hidden things. So you don't see the result, at least you see a new road, you see a new bus line, you see a new railroad, a new station, a new parking lot. You don't see a new system for regulation of traffic lights. So that's a very queen problem in France. But anyway, now they have very strong incentives to monitor CO2 emissions and pollutant emissions. And we can show them that we have very cost-effective solution that they can see the results within 2 or 3 years. So that might be the right thing to tell to them. You have on-the-shelf solution which can address some types of problems that you have, and they can be developed and implemented in a few months, a few years, at a very low cost. But what I will always tell them is that it's not the technology which makes the solution good or bad. The technology only at the serve of their political goals. So they have to address and to know what they want, what is their objective, and then you can find a technical solution that will address their needs.
Any additional suggestion for this minister's memo?
But again, I mean, if I look at the studies we have done, we've seen the biggest CO2 reduction potential comes from, on the one hand, in the vehicle, it's everything that has to do with eco-driving. Okay? So just focusing then in a country like Scotland on the big fleet owners, and I mentioned the story of the postal services before. You know, those who are having big fleets and try to install and drive eco-driving big time, eventually with incentives, will already have real measurable outcomes. And second, when it comes to infrastructure, it's really traffic management systems, especially the traffic lights, you know, better coordination of those systems, where again, I mean, a study done by the German Automobile Club, ADAC, together with the University of Munich, where they kind of looked at reducing of emissions of using what they call green waves, so where traffic lights are really coordinated. That study showed the potential CO2 reductions were there 15%, minus 15%, but more important from a city context is the NOx and the pollutant emissions was minus 33%. Yeah? So again, I think sometimes the problem with all these discussions around ITS that we are overwhelmed by what's out there, and sometimes it's a question of, you know, let's just pick one or two and focus all our attention to that, but get them to a successful result.
Okay, thank you. Yeah, Florence.
Yes, I would just add perhaps also that we could mention the massification of uses that ITS can propose. I think it's a very strong issue as well, carpooling, sharing, mobility issues, actually as solutions to make best use of existing infrastructure. And this is linking also for our transportation. I think it's an important issue as well.
Yes.
Okay. Well, we're coming to an end. I will just launch a final question to the speakers and perhaps the room. We have heard in the beginning of the session some very convincing examples of in the C segment from Ole about the rationalization and the reduction of mobility, some kind of reduction of mobility in sea transport. It was not so obvious for other modes. It's not so obvious at all that all the family of ITS solution will really rationalize or reduce. There are some mechanisms, we've heard about some, but globally, if we consider the movement to autonomous or automated vehicles and all these kind of solutions that are not directly or intentionally intended to climate or environment by fundamentally for the market of mobility, we could say, should we say, that ITS are building a new mobility offer, future mobility offer, that should be more convenient, more comfortable, it's a criterion you use, cheaper, cost-effective, safer. Will it be truly safer? Autonomous vehicle will see its expectations, and we have to prove. And the route to real safety of the autonomous vehicle is long, certainly. More time-saving, or able to keep your time for better use than driving. Easier to plan and accede to transport offer. Greener, and basically more valued by users. Creating this new mobility offer, are we reproducing the old fatal scheme that if you make it easy, the demand will boost and generate more and more problems? Shall we produce in 10, 20 years over-mobility? Because the mechanisms for over-mobility are stronger than the weak mechanisms that can reduce it or rationalize it. A few words by any of you on that, just for a final round. Eric?
Well, I mean, you describe it almost like a doom scenario, and so I think there is. I would look at it in an optimistic and a positive way. I think this new solution, at the end of the day, ITS is a means to an end, so it's not an objective as such. So it's a means to an end, and I'm pretty confident, especially with what we already have seen coming into the market, that ITS will enable more effective mobility solutions, more integrated. I think that's going to be important, more integrated. I think the issue still is cost, because frankly that's why we don't see further expansion, and that's also what I see when I just look at my narrow world of automotive. Yeah, okay, you could offer more to consumers, but then the price would be extensive and people wouldn't buy the vehicle. So getting that cost under control will be another important element as we are moving forward. But I think it's going to go for the better. So I see it as a positive development. And so we should just embrace it. If we do not do it as Europe, other regions in the world will just bypass us, because let's not forget, at the end of the day, this is also about the competitiveness of Europe. It's about jobs, it's about growth. You know, if you look at what the US is doing, if you look at what China is doing for the moment, they just are looking forward, they embrace it, and they have this can-do mentality which we do not longer have in Europe. We only see the risks and the issues, and we feel like overwhelmed by the issues and then get stuck. Yeah? So let's avoid that we fall in that trap. Let's move forward in a positive and an optimistic way.
Okay, one. Ole.
Yeah, what's there to add? I think we are not here to talk about ITS again, as I said before, as the core solution for everything. I think mobility is a basic human need. It's proven how mobility is contributing to growth for both individual level and society level. So mobility should be a good thing. We are all individuals. We make different choices based on different criteria. And back to the thing, make conscious choices or enable conscious choices. Don't regulate on stovepipe solutions and technology. Regulate on enabling sharing of data. Regulate on requiring, providing data. Think of connecting assets that can give interesting insights about how the infrastructure behaves. And then trust the good human capability of making good choices. I think that's the...
Oh, okay.
If you are consciously informed.
So,
Wow. We have seen that technology in the past may have a very bad effect. And just fighting and reducing congestion. We have example in which, well, you put green waves. So you reduce the congestion at one point, but you just shift it a few miles away. So technology is not an answer by itself. What I heard that we have now with those sensors and with all those data, capability and capacity to treat and to have a better knowledge of the mechanism and the impact, positive or negative, of each technology can have on the global welfare. And we are convinced that we need some regulation. We cannot wait 5 years to test what will be the result of each choice driven by the market. We have to put and make decisions right now for the future of our children. And probably some policy, some regulation is necessary so that the technology can be as possible and as positive as possible.
Okay, that was the third. And now finally, Stephen, you're the closest from the street user.
Yeah, I think on our way to driverless vehicles, I think there's a number of gains in driver assistance technologies, roadside to vehicle, roadside to bike technology that can improve traffic safety, like pedestrian detections will be standard in many vehicles very soon, eco-driving, optimization of traffic signals. So I think I'm sure that the technology can help us improving quality of life for citizens. And then when you're talking about driverless vehicles, I think, as our mayor said yesterday, it's very much a matter of which scenario you have. Because if it's individual only, then we still have the challenge of the space, the area in the cities, which is not unlimited. So we have to prioritize with many other purposes in the cities to get healthy and livable cities. If you're combining driverless cars with the sharing economy, it may be more effective and actually give more space to other purposes in the city. So there's a lot of questions to be answered yet.
Of course. Many thanks for you all speakers and for the public.
Be interested to
Thank you.
some information from the
Good presentation.
Thank you.